Today, we're looking at the inverses of matrices. Not as bad as that last time. You guys all know that. It sounds bad. So, the inverses. We're going to be looking at getting the additive inverses and the multiplicative inverses. Exciting, I know. So, for the additive inverse, we want to add to get the zero matrix. We want to find a matrix and add the matrix we have so that we can get the zero matrix. Zero matrix is just a matrix of all zeros. What we do for that, we just switch the signs. If I have a matrix A with 2, 3, negative 2, negative 1, what is the inverse, the additive inverse of that to be equal to? Negative 2, negative 3, 2, and 1. Okay. So all we do, switch the signs. And if I add these two matrices together, make them I get a bunch of zeros. So I'm going to have negative 2 plus 2 is 0, negative 3 and 3, and then negative 2 and 2, and negative 1 and 1. That's all we have to do for additive inverse. Find the additive inverse. Not that much of that. What parents we got? Yes. Get a little more complicated. So, multiplicative inverse.
Write it down. Oh, I got it.
You good? Ready for this? So, the identity matrix is so. For additive, you want to add to get the zero matrix. For the multiplicative, you want to multiply to get the identity matrix. We'll only be dealing with 2 by 2 matrices. The identity matrix is like the matrix form of 1. It is 1 on the diagonal, and everything else is 0. That's all the identity matrix. Today. So, we have a formula for that. It's called the multiplicative inverse formula. So, we have a matrix A is equal to A, B, C, D. We have that matrix, the inverse of A. Is 1 over AD minus BC times by the matrix B, negative B, negative C, A. What's 48 plus 32? I sure can. Okay, so now that we all have this written down, we have this matrix here, and we have to multiply everything in it by 1 over 81.
Oh my God.
Okay. So, we will end up with a matrix. Once we multiply this scalar into everything, we have 8 over 81, 3 over 81, we have 11 over 81, and 6 over 81. Oops. No. So, we're almost there. We just have a couple of fractions here that can be reduced. 3 over 81, 6 over 81. We can reduce those fractions. And that's all. So what do we get when we reduce 3 over 81? Yeah, that'll be our final answer. Over 27? What over 27? What about 6 over 81? Two over 27. And anyways, that's our final answer. If we multiply, okay, now if we multiply this matrix to this matrix, then we can take it. That's what happened. We just found the inverse. So this is our original matrix, right? All the way down here, we found the inverse of it, right? If we multiply, if you want to multiply this matrix, the first matrix, you'll get the identity.
So it doesn't answer.
But if you're asked to find the inverse, this is all you have to find. You will.
Just multiply.
Multiply together. Just like when we have the additive inverses, we add them together, we get 0. Here we get the small or the identity. Huh? Any other questions on this? No. This is that same 2 by 2 matrix, ABCD. If we take AD minus BC, we get 0. We won't have a multiplication. Everybody know why? Because it's 0. And in our formula, here is our AD minus BC. And that is 0. What do we get? You get a 1 over 0, which is undefined. You can't multiply a matrix by something that's undefined. Okay. So any questions on the determinant? No? Don't do that. Some questions you're asked, just so we using multiplicative inverse to solve linear equations. Another formula. So, here we have a system of linear equations. We want to solve this using multiplicative inverse. So the first thing I'm going to do is put this into matrix form. I have two matrices. One for the left side and one for the right. But 6, -1, -4, and 7. The coefficients. And that's equal to 6, -0.3. Then from here, once I have these two matrices, I just put it into the formula. Xy that is equal to 1 over AD minus BC. So here, our A is 6. In this matrix for our ABCD, for our ABCD, 6 times 7, subtract -1 times -4. Then multiply 2, 7, 6, 1, 4, and our G1, G2 matrix, which is just 6, -0.3. We get 1 over 38, 9, 7, 1, 4, 6, 6, -0.3. Now we multiply that 38. Got 1 over 38 into our matrix. So we're going to get 7 over 38. 1 over 38. 4 over 38. And 6 over 38. Another matrix along. So how do we go within that? We're going to take our row 1 times by our column 1. We have 7 over 38 times 6 plus 1 over 38 -0.3. Okay, so we found out this from our multiplying. Went through, added together, and we got 1/2 at -3. And this is equal to, remember all the way at the top, is equal to xy. Matrices are equal if they have the same dimensions. Corresponding parts are equal. So what is x equal? What is y equal? That's how you figure that out.